Alright, so today we're going to go over the accelerometer in the Raspberry Pi. So that's going to measure going in a straight line and going straight and then straight up and down. So we already did the gyroscope that did the rotations and the spins. So again, the accelerometer is going in the straight lines, and that's what we're going to measure today. Okay, so what we are going to do is we're going to measure the pi moving in a straight line, and we're going to use the accelerometer for that. Okay, so to get started, what I already did is I created a accelerometer .py file that's on my Raspberry Pi, and then up here I already imported the command for the sense hat and then the time function. And if you don't have the sense hat installed, you can do the pip install, and you can install that now. The next thing we have is the instance, and then we have the variable. So we're calling our instance sense. All right, so to get this to change, what we're going to have to do is we're going to have to do a while true. And put that in a loop. And, this loop's going to continue because there's no break in it. So it's going to really just kind of repeat this acceleration. And if I move this print over and I save this and I run this, it's going to kind of reproduce that number over and over again. But it's going to be really quick. So just kind of show you that, if I run my Python accelerometer.py, all those numbers are going by really quick. And we don't want that. So I'm going to hit Control C and break out of that. So how do I stop that? Well, that's where our import time comes in. We can sit there and say, I want this to sleep. And we'll just do 0.5, right? That way it comes by, quick enough, but not so quick we can't read it. So I'm going to go ahead and save this. And now we're kind of running this again. And again, it's bringing back that dictionary. So I have my X value, my Y value, my Z value. And if I pick up my pi and, I move it, around, it will read that. And notice it's just kind of going in a straight line because we're doing the accelerometer. Like if I go like this, that would be the gyroscope. And the accelerometer reads just again, straight lines. Okay. So that's pretty much it to kind of get that repeated. Okay. So let's get this cleaned up a little bit because these numbers are kind of long. Okay. And we kind of want to make them easier to read. So let's Control C to break out of this. And we'll go up here to our code. And what we want to do is we want a new value for X. And we want to call the acceleration. And since this is in a dictionary already, we just want to call the X value. Okay? So we'll call the X value. So basically when we call the acceleration, it gives us this dictionary right here. Then when we say acceleration and we want to use the key value of X, it's going to bring the value. So the X is the key and the value is this number. So we're going to bring back this number. Okay, so we need to do that for the Y and Z. So what we're going to end up doing is we'll just copy that so we don't have to type it over. Change our values to Y and Z respectively. Okay, so now that we have these X, Y, and Z, well, the next thing that we're going to want to do is we want to type up the X, Y, and Z. To do that, what we'll end up having to do, we're just going to comment out our print acceleration. And we're just going to make a new print statement. And then we're going to have our F string. And then we're going to have X equals. And then we're going to say that we want to call X. and we want that to be a 3 decimal float. So I'll do the .3f to kind of get that in there. And then I put a comma right here at the end for the next value. So this x is just what I'm printing out, x equals, so that's just a print. Now, what I am calling is this x, which is this x up here. And then it's going to say, I want this acceleration x, which is this number down here. And then I only want 3 decimals, so it's only going to bring back 1, 2, 3. It's going to bring back these first 3 right here. And that's pretty much it. Now, what we're going to end up doing is we need this for our y and our z and take out that trailing comma. And then we're going to do y. Going to change this to y, and we're going to change this to z. And then I'm going to save this. And now when I run this by calling the accelerometer, now everything is in 3, and if I pick up my pi and I move it around left and right, up and down, it's going to change those numbers. And getting it to read is, simple as that. So, what's next? Well, how about we use these numbers and then we kind of detect what the shake's going to be, and then we'll make a dice out of it, or a die. All right, so what can we do with the accelerometer? Well, we can create a dice right there, or a die because it's only one, but I can shake it and see it changes to 6, shake it again. So I roll a 6 again. Now I rolled a 3, shake it again, roll a 5, and then, so if you're missing your dice and you needed to play a game, you can use your Raspberry Pi to do it. So I'm going to show you how to do that. So if all that sounds good, let's get started. Okay, so I went ahead and I broke out of my code. I import the random because we're going to need to figure out what a random number is. So how do we get started to make this into a dice or a die? How do we do that? Well, first of all, we know that the LED lights can be kind of bright. So let's do the sense, and then we'll do the low light equals true. And that way that light's not as glaring. Well, the next thing we need to do is we need to kind of figure out when we shake it, what's that threshold, because we don't want to accidentally bump it, the number change. We don't want someone to hit the table and the number change. So how do we sit there and actually do that? Well, we have to define a shake value. So let's say that shake threshold is a 1.5. Okay, sounds like a good number to me. Well, we have that. Well, the next thing we want to do is that, I forgot to put my colors in. So let's do the color of our LED lights, okay? So that's going to be red, green, blue, because it's all in RGB. And I'll just put down an RGB behind there. Then we need the background color, which is going to be nothing. So that's going to be 0, 0, 0. Okay. So now we have that. So we have the shake threshold, and we got the colors. Now we're going to go back to the shake threshold here in a little bit. We just wanted to kind of declare that variable up front, and then we have the colors already defined. So now we need to kind of show what those dices look like, right? So we need the dice, right, equals, and then we'll make it a dictionary. And then basically here, what we have to do is we need a 1, a 2, a 3, a 4, a 5, and a 6, okay? And basically inside this dictionary, we need to define the key values. So if it's a 1, I want to light up the LED lights on my Pi, because remember, it's an 8x8 grid, so I want to go over 3 on the X and up 3 on the Y, right? So I'm going to say that's the 3 from X value and 3 from my Y value. Okay, so that's going to be one value right there. So I got my X value 3 and then the other 3. Now if I make the 2, what we're going to have in the 2 is we're going to make that a diagonal. So that's going to be 1, 1. And then we're going to do 5, 5, right? And basically what that's going to end up doing is on my Pi, it's going to put a dot in my 1, 1 value, my 5, 5 value, and it's just going to be a diagonal. So you know how the 2 is a diagonal on the die? That's basically what we're doing there. And we're going to do the same thing for the 3, 4, 5, and 6. So just so I don't have to type this all in there, I'm going to copy and paste that over. So right here we have the 3, and again, these are 3 different sets of lights. So that's the XY, XY, and XY. And that's going to make the 3. And then down here, 6. Obviously, we have 6 dots. So we have 6 sets of the X and Y value. So how do we draw that out now? Well, let's build a function, right? That's basically, we'll draw that dice out. And we're going to have to pass in the number because we need to know what number we're going to use as our key value. So the first thing we want to do is we want to clear out the number. So if it had a previous number in there, we just clear it out. Then we want to identify the dot in the dice, right? And then we want that to be the number, right? So if I look up here, we have the dice number like right here. So if I pass in a 4, it's going to bring me back these right here. These would be my dots. 1, 1, 1, 5, 5, 1, and 5, 5. So those would be my different dots. So then what I want to do is I want to display them. So I got to set those pixels, right? And then it's going to be dot 0. And then it's going to be dot 1. So the dot 0 is my X value. My dot 1 is my Y value. So if I look up here at the 6, you know, that's 1, 1, 1, 3, 1, 5, 5, 1. So again, it goes across. And then I need that to be my dot color. So my dot color, so that way I know my X and Y value, what color that dot's going to be. Okay, so that's basically all that's doing. So now that we got that done, now we can go back to the shake. So down here in the raw true section, I can comment out this print statement right here. And I can say, let's measure the shake. So I'm going to take the total of the X to the second power. And I'm going to add that to the Y to the second power. And I'm going to add that, and you guessed it, to the Z to the second power. And then I'm going to square root those results. Okay? And that would give me kind of a rough number, and what that comes up. If it's over 1.75, we'll read it as a shake. If it's over 1.5, we'll read it as a shake. Okay? So that's basically it right there. Now I got to sit there and say if total is greater than the shake, because we said if it's going to be greater than the shake, and it's the shake threshold, we got to do something. Well, we're going to roll the dice, okay? So we'll roll that dice, and then that's going to be a random number. And then it's going to be a random int. And then we want it anywhere between 1 to 6, okay? Because we can roll a 1, 2, 3, 4, 5, or 6, okay? So now the next thing we have is print. And I got my cap locks on, so let me undo that. And then we'll do the F string. And re-rolled A, and then roll. So basically what this is going to do inside the terminal, it's going to show what that number that we roll in there. Now what are we going to do with that number? Well, we're going to draw the dice, right? And then we're going to pass in roll. So basically, we get a random number. It's between 1 and 6. So let's say it's a 3. So it's going to print out a 3 in the terminal. Then the draw dice, we're going to roll it. So we're going to pass in the variable 3. So we go back up here to draw dice, and it's going to say, oh, we're looking for the number 3. Then it says for dot dice 3, and this is wrong here. It's a good thing I went back here. So this is supposed to be for dot in dice. Okay, so going back here, so for dot in dice 3, it's going to go up here and say, okay, here's 3. So we got the 1, 1, 3, 3, 5, 5. So we're bringing this back. Then what it's doing, it's saying, okay, inside that we're going to set the pixels. So 0 and 1. So it's going to say, okay, this is the first dot, 3, 3 is the second dot, and 5, 5 is the third dot. So we'll actually have those numbers in there displayed. And that's really what we have to do to kind of get where we're at like right now. Okay. So we do want to add another sleep in here. We want to do this inside the loop. So we're going to do dot sleep, and we're going to do a 1, and just to wait a second before we go to the next one. Okay. Now outside the loop, I'm going to keep this as actually I changed it to a 0.1 just to kind of give it a little bit extra in case somebody bumps something. We'll kind of keep it kind of steady there for a second. And that's pretty much it. So if I hit Control S and save this and kind of run this, I have an invalid up there in line 15. So if I go up here to 15 and take a look at it, we have, oh, you know what I did? I forgot my commas at the end. Okay. So I forgot my comma right there and right there. So just make sure you have the comma. All right. So now I'm going to go back here and kind of run that again. And this is unsupported tuple and a float. So why is that? Okay. I see. My error is right here. I added a comma in my total for some reason. There we go. So apparently I put commas where they're not supposed to be, and I omit commas sometimes. Okay, but anyway, I progress. Right here should work. I fixed that on that comma on there. So let me go ahead and run this. And then everything should be working now. Now if I pick up my pie and I look at it, I have a 4 on there, and I shake it, and it says random is not defined. Oh, because I put an OM in there. Man, I'm making all sorts of mistakes today. So let me go back over here to random. And we look at that. That's what, line 38? Okay. Random. Save it. And then I run this. Okay, now if I pick up my pi, it has a key error called number. Why? So we'll take a look at that. So, because I'm actually passing in the number, I'm not passing in a string. Passing in a number, so I don't need that. Now let me run this one more time. And then I'll pick up my pi. And see, it says I rolled a 1. And if we look at it, there's a 1 up there. And I can bring up the video like up here a little bit. And you can kind of see that 1. If I shake it again, see, it has a 3 in there. And if I go back, you'll see that I'll have a 3 at the bottom of my screen. Shake it, it goes to a 4. And I will go back over here, and you see it has a 4. So doing it as simple as that. And then, like I said, I have the comma in the wrong place, and I accidentally passed in a string when I should have passed in a number. But other than that, if you stayed with me, thank you. Sorry for those typos, and we'll kind of move on from here. Okay, so the last thing I'm going to show is probably the magic 8-ball. So as a kid, we always had the magic 8-ball where we shook it and we asked it questions, and through hocus pocus, it would come back and will give us results like, yeah, maybe, maybe not, sure, whatever, it was a magic 8-ball. So how do we do that digitally with the pi? Well, let's think about that for a second, and then we'll go ahead and get started. Okay, so what we're going to end up doing is we're going to just take our old code. We're going to edit it to make it read a magic 8-ball. So the old magic 8-ball used to shake it up and used to ask it questions, and then it would come back like yes, no, maybe, and has a variety of different responses. So the first thing we need to do is we need to come down here and we need to add the different responses that it can be. So I'm going to put that after my color and in front of my dice. So I'm going to do response. And then I'm going to do equals. And then I'm going to have to do the list. So in the old magic 8-ball, there was 20 die that was actually inside the 8-ball itself. So it actually gave you 20 responses. So these here, I copied and pasted in, are the 20 responses from the original magic 8-ball. So you can put in any response you want. Just for the spirit of the magic 8-ball, I'm just keeping the responses the same all the way down. That's pretty much it for the responses. You can edit them. You can do whatever you want. You can make your own responses. It doesn't have to be 20. It can be 3. It can be 5. It can be 50. It doesn't really matter. You have the responses like listed right here. So how do we get those responses back? Well, from the previous program, we know that we already have the shake already defined. And if we go down to the bottom, we also have the total already defined. So we're going to take the original code here and we're going to comment this out because we're not getting the number, for a rolled dice anymore. And I'll probably rewrite this into a function just so I can keep them both in the same program. But I do need this first line of code. And I'm going to put it down here. If total is greater than the shake threshold. Again, we're just getting the shake of the Raspberry Pi. And we want to be sure that we clear that out. Okay. So we clear it. And once it's cleared, we need to have the answer. And that's going to be random. And then from random, well, it's a choice. And where are we getting that choice from? Well, we're getting from our responses. So this is going to pull a random choice from my response right up here. And I got to put an S on it because it's responses. And then, so we get down here, and these are all the responses that it's going to choose. It's just going to choose a random one from this list. Okay, so now that we got the one, now to print it to the terminal, we can just do print answer, and then we can see the answer down here in the bottom in the terminal itself. Again, just so we can check to make sure everything's working. And the next thing we want to do is we want to do a sense, and we want to show that message on the Pi, right, itself on the sense app. So if I do sense message, we're looking for the answer to display. Okay, so we got the answer. Then we're going to look for the scroll speed. And we want to slow that up a little bit. So we'll do 0.05. And then, we have the text color equals. Now I can go up here and I can use the dot color to red because it's already set. Or I can just define my own color. I'm going to just use this dot color. And then I'm going to put it right there. But if I wanted to, I could put the brackets and I could put the RGB numbers in there. The next thing that we got up here, so that looks correct, is we're going to do the time sleep again. And since it's displaying a message and it's scrolling, we're just going to put 2 just to kind of, give it a little bit more time. And that's pretty much it. So if I save this, right, and I can take my Pi and I can ask it a question, right? Well, first I got to run the program. So let's go Pi accelerator.py, accelerometer. Okay, now I can ask the question, is anyone going to watch this? And I'll just shake it, and I have, show me, look at that, I misspelled. Well, let me just kind of copy this little show message right here. And then I'm going to put that right here. And I also know that I misspelled like time. Alright, so I'm going to save this. Now I'm going to run this again. Everything seems to be working now. So I'm going to say, is anyone going to watch this video? And I'm going to shake it. And it had, because it's the English spelling of color. Thank you, British. So it's COLOUR. So hit save. You can thank our friends from the UK. And then we can sit there and run this again. And I'm going to ask the question again, is anyone going to watch this video? And I shake it. And it says yes. And if we look at this, I should scroll the response thing, and it does. So if I I'll bring this up for you guys, and like if you shake it, see, it'll have the right there. It would have that answer in there. So do you guys think this is cool? And it says cannot predict now. Okay. So I can say, what do you want to, well, I have to answer a question, I guess. I can say, are you going to like this video? And it says, as I see it, yes. So hopefully that holds true, and hopefully I get a bunch of likes, and, everyone goes on their merry way. But other than that, I'm talking about, that's pretty much the Magic 8 Ball, and, So thank you for sticking around, and I'll talk to you guys next time. Okay, so as a bonus here, what I'm going to end up doing is I'm going to fix this acceleration. So basically, what I'm going to end up doing is just to make it a little bit easier, I'm going to make a function called get total acceleration. And then, let's see, we'll just call this, like my total. And then it's going to pass in the X, Y, and Z values. And here's what it's going to end up doing. So basically, what we got to do is go down here to this section of the code. And I'll just exit that out. And I'll put this in here. And I'll get the X, Y, and Z values here. And then I'll have the total. And then what I'll end up doing is I'll return total. Okay. Then I just have to call it. So I got to get the total acceleration. And then down here where I replaced the code, or I got rid of the code, I can just put down get total acceleration. And then I have to pass in the acceleration. And it's still going to go through that whole progress to get that total. Now, since I named this total in my code down here, I'm just going to keep my variable the same and just call it total equals get total acceleration. And that's pretty much it. So if I hit Control S and save this, right, and then I kind of run this again, then Python accelerometer, and it does not like my, because I misspelled return. Jesus Christ, I can't spell today. Return. Okay. So now I run the accelerometer and see if I shake it, everything works, like it's supposed to. So shake it again. So that's pretty much it, just to kind of clean up the code. So when I throw this out on GitLab, it'll be a little bit cleaner. Okay, so the next one we're going to do is we're going to turn this into a function right here for our magic 8 ball. So I'm just going to cut that completely out, and I'm just going to say magic 8, right? Because that is going to be my function. I'm going to have to pass some stuff in there. I'm just going to keep it there for a placeholder right now. But if I go back up here, this is our magic 8 section right here. So I'm just going to paste in the code right there. And this is going to be the function magic 8. Okay. So just do this. What am I going to need to pass in here? Well, I'm going to have to pass in total, and I'm going to have to pass in my shake threshold. So basically I need the total and I need the shake threshold, and then all this other stuff we'll call the other functions and it'll just work. So if I go down here to the magic 8 ball, I'm going to need to pass in the acceleration and total. So I'm going to copy that and I'm going to put in the acceleration and total. Okay. So now the magic 8 ball we'll call acceleration and total. It will go up to the top. And that's total and shake threshold. So that would not work because I'm actually passing in total and shake threshold. So if I go down here, I'm actually passing in the total and I'm passing in the shake threshold. Okay. And then let me double check this really quick. Yep, that should work. So now I'm going to save this. I'm going to break out of this, and then I'm going to run my Python accelerometer. And if everything works, it should, yep, it is certain that it works. How about that? So yeah, everything's, working the way it should. So signs point to yes. I'm talking about the magic 8 ball is not wrong, folks. But that's pretty much it. And we'll do the same thing for this section of the code. And let's do this. Like, we'll call this one let's see, roll dice, right? And this is going to be the same thing. I'm going to have to pass in the total and the shake threshold. And I'm going to comment out my magic 8. And I'm going to bring back, I'm actually going to cut this. And I'm going to go up here. This is the end of my dice program. So I'm going to put my function right here and just say DEF. And then paste that in there. And then what I call it down here, I called it roll dice. And I'm just going to go up here, keep it roll dice, and then just kind of put my colon there and hit save. And if everything works correctly, now this is going to kind of roll the dice for me. So let me Control C and break out of my Pi, rerun the accelerometer. It's rerunning. Shake it. Reroll to 1. Roll to 2 to see it's working the way it's supposed to. Roll to 6. Okay. So now we know that works. So pretty straightforward.